Hi, so in this video we're going to look at integration by parts. This is a process by which we can integrate two functions that are multiplying each other, so products of each other, that substitution is not going to be able to deal with. We can think of this as the reverse process of the product rule. Okay, so this formula, the integral of f of x times g dashed x will equal f of x times g of x minus the integral of f dashed x g of x. Okay, so the first thing to notice is it's not given in the exam. The second thing to notice is that when we're looking at our two original functions that we're integrating, we're treating one of them as having been differentiated already. Okay, so the whole point, what you're going to do is, of the two functions, decide that one of them is going to get differentiated and one of them is going to have to be integrated. So the one that you choose to be differentiated is the one that's going to simplify by being differentiated. Okay, so what you can hopefully see is, if I choose to differentiate cos x, it's going to become sin x. That's not any simpler. But if I choose to differentiate x, it's going to become 1, which is simpler. So the first thing we can do is choose, say, that f of x equals x, which means that f dashed x will equal 1. G dashed x, therefore, is cos x. And so g of x must have had to have been sin x. Okay, so then we can say that the integral of x cos x dx will equal f of x times g of x minus the integral of f dashed x g of x. So the integral of x cos x dx will equal x sin x. Integral of sin x is negative cos x, so it's going to become plus cos x, as there's already a negative outside the integral. And then don't forget that it's going to be plus c. Okay, so let's move on to another example. So here we have e to the x times 2x plus 1. So what function is going to simplify by differentiating? Well, it's going to be the 2x plus 1. So let's say f of x equals 2x plus 1, which means that f dashed x is going to equal 2. So g dashed x will equal e to the x. So that means g of x must have had to equal e to the x. Okay, so therefore we can write that the integral of e to the x, 2x plus 1 dx equals f of x times g of x minus the integral of f dashed x times g of x. So the integral of e to the x, 2x plus 1 dx will equal e to the x, 2x plus 1. Integral of e to the x is just e to the x, so it's minus 2 e to the x plus c. And if we really wanted to simplify it further, we can take out the common factor of e to the x, leaving 2x plus 1 minus 2, which will just be 2x minus 1 plus c. Okay, so looking ahead to the next question, we're going to have to do integration by parts, and then we're going to have to do it a second time. And the reason why is because I'm going to simplify this at first, but it's going to simplify from x squared to just an x term. So we won't have fully fixed the problem. We'll have made it simpler, but not fully simplified enough to just integrate it. So all we do is integration by parts twice. So f of x equals x squared. So f dashed x equals 2x. G dashed x will equal sin x, which means that g of x must have had to have been negative cos x. So we can rewrite that x squared sin x dx will equal f of x times g of x. So we're going to end up with negative x squared cos x minus the integral of f dashed x g of x, which is going to be 2x negative cos x. So I'll rewrite that as x squared sin x equals negative x squared cos x Let's take out the 2 and the negative, so it becomes plus 2 integral x cos x. Okay, so hopefully there you can see that I can't integrate that yet. However, I'll just do it a second time. So we can do f of x equals x, which means that f dashed x equals 1. So g dashed x is cos x, and g of x equals sine x. So we get integral of x squared sine x dx equals negative x squared cos x plus 2 bracket integration by parts within the function. So that's going to become f of x g of x. So x times sine x minus the integral of f dashed x times g of x. Close brackets. Can break that out and I'll get plus 2x sine x minus 2 of the integral of sine x, which is just negative cos x, plus c, and just to make it neat, integral of x squared sine x dx will equal negative x squared cos x plus 2x sine x plus 2 cos x plus c. Okay, so that is integration by